In 2024, the world still depended on fossil fuels for more than 80% of its total energy use. And despite record growth in wind and solar, coal remained the single largest source of electricity, and it generated over 1/3 of global electricity supply. At the same time, international climate agreements have set ambitious targets for reaching net zero emissions by 2050. But while most nations are still debating how to get there, a small group of cities has already crossed the finish line. These cities represent different pathways to the same outcome, proving that 100% renewable systems are not only possible, but they are also reliable, affordable, and even scalable. Iceland's capital, Reykjavik, generates over 99% of its electricity from renewable sources, making it one of the greenest cities on Earth. But how did this city harness the forces of fire and water to create a fully sustainable energy system? Reykjavik's renewable energy success starts beneath the city itself and in the rivers that crisscross the island. Fast-flowing rivers generate most of the city's electricity through hydropower, while underground heat for volcanic activity provides geothermal energy. Together, they supply clean power for homes, businesses, and public services. One of the city's most remarkable innovations is its district heating system. For over 50 years, Reykjavik has been using geothermal energy to heat the city's homes and commercial buildings. When hot water from underground reservoirs is pumped to the surface, the rapid change in pressure and temperature produces a huge amount of steam. This steam turns the blades of a turbine, which produces electricity for the city, and the remaining cool water and condensed steam is pumped back into the underground to create an open loop that can generate electricity without losing water. At the heart of Reykjavik's renewable network is the Hellisheia Geothermal Power Station, which is the largest geothermal facility in Iceland. It produces both electricity and district heating for the capital, and it exemplifies how geothermal energy can be a dual-purpose solution. Beyond electricity and heating, Reykjavik is also actively working toward carbon neutrality by 2040, and it is aiming to reduce emissions from transport, industry, and municipal services. Reykjavik's model has caught the attention of policymakers and environmentalists around the world, and it shows that with abundant natural resources, innovative engineering, and committed policy, urban centers can operate entirely on renewable energy. In 2009, Basel became one of the first cities in the world to switch its entire electricity supply to 100% renewable sources. Today, every light that is switched on in this Swiss city runs on clean power, without residents needing to pay extra money on their bills. Located along the Rhine River and bordering both Germany and France, Basel may not be the largest city in Switzerland, but it has become one of the most ambitious when it comes to renewable energy. Through a combination of hydroelectric power, solar, wind, and district heating, Basel has redefined what a city's energy future can look like. Unlike in many other cities, residents don't have to pay a premium for green power, and it has become the default source of energy for the city. With abundant rivers and alpine reservoirs, hydropower supplies the majority of Basel's electricity. The city also invests in wind farms, solar projects, and even pump storage facilities like Nanta Drance in the Swiss Alps, which act as giant batteries for balancing supply and demand. When electricity demand is low, for example at nights, excess electrical energy from the grid is used to drive pumps and pump the water from the lower lake up to the upper reservoir. When the energy demand is high, the stored water is released back down from the upper reservoir, and it flows through turbines that convert the water's kinetic energy into electricity. This diversified mix ensures that Basel's renewable electricity is not just symbolic, but it is reliable for the entire year. The city has also invested heavily in local projects that complement its clean electricity system. Rooftop solar panels cover major sites in the city, and they are feeding clean power directly into the grid. A waste-to-energy plant recycles the city's waste into electricity and heat, while its modern upgrades have improved its efficiency and reduced its emissions. These initiatives show that Basel's renewable strategy is not just about ambitious targets, but it's about creating sustainable energy systems right within the city. In 2014, the city of Burlington in Vermont made headlines when it became the first U.S. city to run entirely on renewable electricity. Nearly a decade later, it remains a rare example of how a city can power itself without fossil fuels. By combining local generation with long-term contracts for renewable power, Burlington ensures that 100% of the electricity that is delivered to its customers each year comes from renewable sources. Burlington's renewable portfolio is built on 4 pillars: biomass, hydro, wind, and solar. At the heart of the system is the McNeil Generating Station, which is a 50-megawatt biomass facility that burns wood chips from regional logging operations. While it is still controversial, and there are debates over its environmental impact, it can provide a steady power to the city. In 2014, Burlington purchased the Winooski 1 hydroelectric plant, which is a 7-megawatt dam on the Winooski River. That acquisition was the tipping point that officially pushed the city past the 100% renewable threshold. Wind energy also plays a key role. Burlington has long-term contracts with projects like the Hancock Wind Farm in Maine, which supplies about 9% of the city's electricity needs. Finally, there's solar. While it makes up a smaller share, rooftop arrays at the airport, schools, and municipal buildings contribute to the local grid. Together, this mix ensures that Burlington can match its annual electricity demand with a clean, renewable supply. Running on 100% renewable power doesn't mean the city is fossil-free at every moment. Instead, Burlington balances its load over the course of the year, and it reduces the overall use of traditional power sources. When local plants overgenerate, the city's utility sells its excess renewable credits into the regional market. When output falls short, the utility buys renewable energy credits or contracted hydro and wind power to make up the difference. This careful portfolio management allows Burlington to maintain its 100% renewable electricity claim, even as older contracts expire. In general, the race to build renewable cities will depend on both technology and policy. Advances in energy storage and smarter grids will make these transitions faster and more reliable. Meanwhile, international climate agreements are pushing governments to accelerate their timelines. As we will probably see in the future, the next decade will determine whether 100% renewable power for cities remains the exception only for advanced and wealthy countries, or it becomes the global standard that can be used in every city around the world.